Chapter 2 Annex, you have already studied about the energy recovery in reverse osmosis desalination. Now I would like to talk to you about the last generation membranes. As you may know, reverse osmosis is an energy-intensive process in which high pressure is required in order to remove the salts contained in seawater. Around 70% of the total energy required is used in the reverse osmosis system. That means the reverse osmosis rack, the high pressure pump, and the booster pump included in the energy recovery system. Many efforts have been made in order to improve the specific energy consumption by using these devices. Efficiencies up to 98% have been achieved in isobarite chambers, so no much more scope is left for further reductions by using these devices. Energy saving efforts should be made in the field of membranes. Reverse osmosis energy consumption has been reduced by 60% in the last 20 years. We can see in this slide that at the beginning of the reverse osmosis history, we had specific energy consumptions of around 12 kilowatt-hour per cubic meter of desalted water, and nowadays we are below 2 kilowatt-hour per cubic meter. Are not only associated with the improvement of the energy recovery devices, but also with improvement of the last generation membranes. The so-called last generation membranes have achieved increased salt rejections, reduction in operating pressure without productivity loss, all this by increasing the specific surface, membrane surface. Here we can see that at the beginning we had membrane surfaces of 380 square feet, and nowadays we have membrane surfaces of 440 square feet. All these advances entail reduction in costs and energy. A very important innovation in reverse osmosis membranes is the use of nanotechnology in order to change the surface structure of the membrane. Here we can see the nanoparticles used in the synthesis process of the traditional polymer film. With these innovative membranes, we can reduce the energy consumption by 20%, increase the production capacity by 70%, and all this permits to reduce the reverse osmosis plant size by 40%. Here we can see different manufacturers of 8-inch seawater reverse osmosis membranes. They are all last generation membranes. Reverse osmosis rack's standard configuration consists of various pressure vessels allocating between 6 or 7 elements placed in series. Increasing the membrane flow increases the imbalance between the first element flow and the last element flow. Increasing the membrane flow increases the risk of biological fouling. We can control the flow of the elements in the first positions by applying a back pressure on the permeate. But this would increase the feed pressure required. There is a more elegant solution in order to improve the hydraulic balance of the pressure vessel. This is the internal stage design or the membrane hybridization. The best combination is to allocate high salt rejection elements in the lead positions, high productivity and low energy requirement elements in the middle positions, and high productivity and very low energy requirement in the last position. By using this innovative design, we can reduce the number of pressure vessels in a reverse osmosis rack between 5 to 10%. Also, energy savings costs will be reduced by 2 to 5% when this design is used to reduce the operating pressure. The most efficient use of this innovative design is when you maintain constant pressure and the feed flow, and you increase the recovery rate of the pressure vessel, its productivity. Finally, I would like to highlight that the energy cost is the largest operation cost in reverse osmosis, is around 40% of the total cost. The specific energy consumption has been reduced by 60% in the last 20 years. We have passed from 8.5 to less than 3 kWh per cubic meter. All this mainly due to the energy recovery efficiency achieved with the energy recovery devices is up to 98% of efficiency. The reduction of the operating cost has allowed the increasing of the aero desalination technology use. There's no much more scope for further reduction by using these devices, so the energy saving efforts in reverse osmosis should be made in the field of membranes. And finally, what I have presented, that last generation membranes development have achieved higher flux and lower energy requirement.